Hello and welcome to my last video on integration by parts. So if you're watching this right now, you've most likely seen the first three videos I've done on integration by parts. If not, this video will probably be a little confusing. I like to make videos as attainable as possible to kind of follow along, but integration by parts is one of those topics where they can get super crazy. And this question alone, it's over a page long, like if you write it on paper. So it's pretty difficult, but if you're here watching this right now, I applaud you. I warn you that it's going to be pretty difficult, but I think we can get through it, okay? It's going to start out looking super simple, and then it's just going to blow up, like a lot of stuff in calculus does. So yeah, let's just get right into it here. So, the integral we're going to be looking at is the integral of secant to the fifth x dx. This nasty bugger right here takes about a page and a half to solve. Okay, so the first thing we're going to do is like this 5 year really messes things up. Lots of time in calculus and algebra, your trig identities, all that stuff, your differentiation. We're used to seeing secant squared. Okay, so instead of writing secant to the fifth, let's write it in terms of powers multiplying. So we want this secant squared to be kind of in the equation. And if it has to end up as secant to the fifth, we got to multiply it by secant to the third x dx. So these are equivalent expressions here. Okay, so instead of thinking of it as secant to the fifth, we'll think of it as secant squared times secant cubed dx, okay? So now that we have it like this, we can't really use that acronym that I talked about before, the LIATE, because it assumes that the factors are different kind of um, ways to represent like different functions. So we don't have any logs, no inverse trig, no algebraic. We do have trig, but both of these are trig. So we kind of have to use our brains and think, what are we going to have to be doing in integration by parts? Well, when you choose your u, right, you're going to have to differentiate that. So we want to choose between these two, which one we can differentiate. And for the other one, we're going to start with dv and we're going to integrate that. So the other one is going to be what we're starting with as our derivative. We're integrating that to get our v. So we know how to integrate secant squared of x, and we know how to differentiate secant cubed because it's much easier to differentiate things than to integrate them, generally speaking. So just from kind of thinking about that, how like thinking into the future what we're going to have to be doing, we're going to set u, okay, we're going to set u equal to, um, we're going to set u equal to secant cubed x du. Secant cubed is really just secant x to the power of 3, right? So if we use our knowledge of integration by substitution, or sorry, if we use our knowledge of differentiation and the chain rule, right? We know that this is just 3 times the inside, which is secant x squared, times the derivative of the inside. The derivative of the inside of secant x is going to be secant x tan x. Okay, so this is going to be our du. And as you can already see, it's getting a little bit ugly. Just wait. Those are my words to you here. But we can do it, right? 3 secant squared x tan x dx. Or sorry, secant squared x tan x secant x dx. We have secant squared and secant multiplying. So this whole thing, those two parts are going to become secant cubed. So we can kind of simplify that a little bit. It's going to be 3 secant cubed x tan x dx. Okay, and then dv and v are a little bit easier. dv is just this other part here, secant, or secant squared, my bad. And then in that case, and then we have our dx here. Our v is going to be tan x, right? That's something that we can use our table for. Okay, so the let's see here, the integral of secant to the fifth dx. I'm gonna write that here. That's going to be equal to u dv, right? Our u was secant cubed. Or sorry, our uv. Our u is secant cubed. V was tan x. So we got tan x here minus the integral of v du. So v was tan. Du was 3 secant cubed x tan x dx. So I'm going to bring that 3 out front. So we're subtracting 3 times the integral of secant. Actually, no, I'll write tan first. So tan x, that was our v, and then our du was 3 secant cubed tan x dx. Okay. So now that we have that, let's multiply these tans together. So see how there's like kind of surrounding the 3 secant cubed, there's tan x and tan x. Let's just make that tan squared x. And I don't know why I wrote 3 here. That shouldn't be here. We already took that out. But even though it's hard to keep track of everything going on, this is tan squared x secant cubed x dx, right? So what are we going to do now? Well, I'll tell you that tan squared x is something that we can utilize an identity that we know with. Okay, so tan squared x, all right here, tan squared x, that is the same as secant squared x minus 1. Okay, so that's just a trigonometric identity that you can use. So once you plug in secant squared x minus 1 for tan squared, I'm not going to write this out here. Secant to the fifth dx equals secant cubed x tan x minus 3 times the integral. When you combine secant squared minus 1 times secant cubed, you kind of expand that out. It's going to be secant to the fifth minus secant to the third. Remember, we still have that dx in there, just hanging out. Okay. Now let's see here. We can. So this we're taking the integral of this entire inside section. That's our integrand. So since there's a minus sign between the secant to the fifth and secant to the third, we can split those integrals in two. Okay, so I'm not gonna write it all out again. I'm just gonna write secant to the fifth x, make that its own integral dx plus 3. Remember it was minus 3. This is gonna be plus 3 now because we're subtracting the integral of secant cubed x dx. Okay, so this is what we're left with. Now, in the last video, I showed you that if you saw something on both sides, you could just bring this to the left side. So instead of having to worry again about like what secant to the fifth x is, like you're just going to keep going in the same circle because that's exactly what we started with. So what you want to do is you want to add it on both sides, right? Add 3 times the integral. So when you do that, we started with 1 over here. When we add 3, we're just going to end up with 4 times the original integral that we're integrating. right? And that is going to equal secant cubed x tan x minus, or sorry, this is going to be, because that minus this whole section here is gone now because we added it, plus 3 times the integral of secant cubed x dx. Okay, good. So it is a bit messy, but we're making some progress, right? We moved these 3 over to the left side, so now there's 4 times the integral of secant to the 5th x dx. And in our integration by parts, we always want to make sure that the powers are going down. So we started with secant to the 5th. Now we're at secant to the 3rd, so we are making progress. The power is progressively going down. So that is a good thing. Okay. So let's see what we can do next. Well, when we originally started this question, remember it was secant to the 5th, and we split it into secant squared times secant cubed. Let's do the same thing here. So instead of secant cubed, let's write secant squared times secant, because that's the same thing. This quantity here is just the same as secant cubed. So we're essentially going to repeat this process. I'm going to have to write really small. Secant to the 5th x dx equals secant cubed x tan x, right, plus 3 times, okay, we're going to have to figure out what the integral of secant squared x secant x dx is going to be. So I'm actually going to write it down over in this space here. Okay, so remember when we're picking our u and our v, we're thinking what can we differentiate and what can we not integrate. So let's think here. Let's let u equal secant, because we can integrate secant squared, right? That's just going to be tan x, so it's going to make it a bit easier on us. And we already know the derivative of secant x. We did it before. It's just itself, secant x times tan x, and we get that dx hanging out there. Okay, and then remember we got to do our dv was just like the inside that we didn't pick already, so it was just secant squared dx, and then v is going to be the integral of dv, right? Because it's an inverse operation. We're going the other way now. Instead of differentiating, integrating secant squared to get tan x. Okay, so if we plug in, if we think about it in terms of our formula, this right here, our integral, that's going to be the same as uv minus the integral of v du. Okay, so uv is going to be tan x secant x, right? And then we're subtracting the integral. V is tan x, du is secant x tan x. So this is going to be tan squared x, because there's 2 tans, secant x dx. Okay. So up here, instead of the integral of secant squared x, or secant cubed x, sorry, when you expand that in, we're just going to write this term, or this expression right here. So it's going to be minus, or plus 3 times this whole integral, which we figured out was secant x tan x, right, minus the integral of secant, or sorry, that's going to be, we said it was tan squared, right? So this was tan squared x times secant x. Instead of writing that, let's use our identity once again. So let's keep this part the same, but instead of tan x, we're going to write secant squared minus 1 times secant. And when you distribute this in, you're going to get secant cubed, right, minus secant. So it's going to be minus the integral of secant cubed x minus secant x dx. Okay. Now, okay, since we are subtracting, we have a subtracting sign in between the secant cubed and the secant. I'm actually going to get rid of this now because we don't really need that anymore now that we figured this out. Okay, so since there's that subtraction sign again, we did it before in this question. We can split this into two integrals, so I'm going to write this out once again. Equals secant cubed. Like I said, a lot of this is just translating what we did before down. So secant tan minus the integral of the first part, right? And since this minus and minus is there, we can say that we're adding the integral of the second part. Oh, actually, I forgot my dx. So we got the dx there, plus integral secant x dx. Okay, we're moving along, all right? So now that we have that, what can we do? Well, we can use our table for the integral of secant x dx. Okay, so there's no way that I'm writing all this stuff again. So I'm going to erase this and try and squeeze in here. The integral of secant x dx, that's just the natural log of secant x plus tan x. I know it's kind of hard to see, but hopefully you can see it there. Okay. So that's going to be your integral. That's just replacing the, when we had the integral of secant x, okay? That's what we can use our table for. We already know that. We can prove it. That's not really the issue here. And remember, we have this bracket still that I got to squeeze in. Okay. So, what to do now? So a little thinking here. We can. So the problem here is the integral of the secant cubed. Let me just think how we could go about doing this here. So I got plus 3 minus 1/2. We could rewrite this because we already did this secant to the cube before, right? So when we rewrite this all out, we're going to get 4 times the integral of secant to the 5th x dx equals secant cubed x tan x plus 3. Okay, so the inside, the start is still the same. Secant x tan x. And then we're subtracting. Once we use our substitution rules, we're going to figure out that we can simplify this to 1/2. To 1/2. This is going to be secant. Actually, we can factor out that 1/2, so it's going to be 1/2 secant x tan x plus 1 secant x plus tan x. So it's kind of getting hard to read here. And once we have this, we can just divide both sides by 4, right? Because it's just 4 times that. We don't have any integrals left on the right side. So we divide all that by 4. And what we're going to get, once we kind of simplify everything, you can check this after, but just to save space, it's going to be, we could factor out maybe a quarter, right? It's going to be secant cubed x tan x plus 3 halves secant x tan x plus 3 halves ln, we have that secant x plus tan x, the absolute value there, right? And then we got plus c. Okay, so this is your answer for the integral of secant to the 5th. Okay, lots of simplification that we had to do over the question, but once you expand this quarter into each of these terms, you're just going to get what we originally had up here. Okay, so I just kind of simplified it for you. You could do it on your own on a separate sheet of paper, but this was kind of a walkthrough on how we could solve this question. It was not easy. We had to use lots of different methods, but we got there in the end, and this is kind of the hardest, like just putting your head down and doing your integration by parts that it can kind of get. It'll get pretty repetitive, like the higher the order of the function is. So like secant to the 7th or 8th, you can imagine how hard that would be. But all it is you're really just repeating this process. So even though the 5 isn't as big as it could be, you just like keep doing this forever and you'd eventually get there. And your answer, like these terms here, would just get longer and longer. So it kind of becomes redundant and not really necessary to practice anything higher than that, because this alone is just, it's pretty ridiculous. But I think if we can go through these questions together and kind of work on them step by step, it helps you apply it into different questions. And looking at this question, comparing it to what we did originally, it just doesn't even compare. So yeah, I hope this helped. Kind of, if you're stuck on any parts, give me a message or go back in the video, kind of look at what we did to get where we got. And I hope this helped. I hope you enjoyed kind of this series on integration by parts, and I'll see you in my next video.